Oh, hey guys, today we're on Mole Creek, which is a tributary that leads into the Milwaukee River, which is where Grafton High School does its water quality testing. Today I'm going to perform a dissolved oxygen test on this river. Have done that multiple times in the past and have always found the dissolved oxygen to be of high quality. So we're going to do that today. I'll walk you through the test. This is a spring-fed creek, which there are actually two springs right over here. You can see my dog in the background. She's looking for some animals back there. And so this is actually my property. I'm lucky enough to have this awesome little spring-fed creek that runs through my 7 acres. So we're going to go through this test today, and I'll hold up some of the test items that you'll have in your test kit. This is one of the test kits from Grafton High School. You'll find a set of directions. It's a multi-page set of directions. So you want to make sure you start on the first page, which is labeled Dissolved Oxygen Test. Going through these pages, there is an additional couple of pages to do the biochemical oxygen demand. I'm not going to do that today, but I'll talk about it at the end, what you would need to do to set up for the 5-day run on this test. We also have a couple of chemicals in here. There are some large powder pillows in these large bins. These are pretty tough to get into, but each kit has a set of large nail clippers that you can use to get in. It's still going to be a battle, so when you're ready to do this, just make sure you give yourself a little bit of time. We also have a test bottle, which also has a lid on it. The lid may be hard to get off. Tapping it on your counter or something will allow that to loosen up, and do that gently. We don't want to break that top portion off, and I'll talk about the sampling procedure with this. In the test kit also is a small square measuring vial and a transfer tube. You'll need these to perform the test. Additionally, in the kit is some dropper. We're going to do a quick titration using sodium thiosulfate. And additionally, and they may be in plastic bags or they may be in these square bins, we have some reagent packets, dissolved oxygen 1 and 2, and these will go into the test at the same time. So it's important to remember when we're down at the river to make sure we collect all of our garbage from the chemical packets so that we don't let them into the environment. So what we're going to do first is we're going to collect a sample, and we'll do that right here below the little bridge that I'm sitting on that goes across my creek here. Alright, so when we test this water, it's important in this testing vial. I'm lucky enough to just be able to lean over the little bridge here, but when we test, we want to make sure that there are no air bubbles in this testing vial. So when I put it underneath the water here, I want to make sure all the air bubbles come out, and then I place that cover on top. I do a little tip here to see if there are any air bubbles. There are not in this sample. If there were, I would just simply pour this back out and resample. These bottles do have a little shoulder on them, so if you put them in only like this, you're likely to trap air here, which is not a good thing. We want to make sure there's no air in this bottle when we do our original testing. So, quick sample there. We also want to make sure we don't stir up a lot of the bottom. Again, because I don't have to get in the river here, we don't have to worry about that. Alright, now that we've got our water sample, we can go ahead and add the 2 dissolved oxygen packets. So I've pre-opened those. We take our cover off, tap any water off. So this is number 1. We want to try to get those chemicals down the throat of the tube, and that just keeps them from attaching to this wall here. So a little bit of care when we do this. It's kind of nice to be able to open these up a little bit. Chemicals come out quite nicely then. Quick little tap, squeeze it just to make sure there's no chemicals. Place that cover back on. Okay. Give it just a tiny little twist. and then we're going to shake back and forth. We'll leave here, shake this back and forth, and what will happen if there's dissolved oxygen in this water, which there is, of course, we're going to end up getting a chemical reaction that occurs with the water in the two chemical packets. And what you'll see is kind of an orange color here. It's kind of nasty, chunky looking. And what that is that's flocculant. We're going to let that settle until it settles halfway down in the tube or in the test vial. Most of these test vials do have a line. This one does not happen to have that, so we'll just kind of eyeball that and go halfway. Settle time will depend on the reaction that's occurring. So we'll just let that sit and come back to that when that's half settled. So you can see real quickly here as this flock is settling, it's starting to clear above. I'm going to let this go maybe another minute. It's been 3 minutes so far, and we'll come back to it. Okay, so that's been another minute. You can see we're about halfway down. The directions now have you shake this bottle again. So go ahead and hold the top of that and invert it a couple of times. Okay, we've got a good mix here, and what we're going to do is we're going to let that settle for another 4 or 5 minutes again before we add the last chemical. Okay, we've waited another 4 or 5 minutes here, and you can see we're down below half again. So we're going to take that top off. Okay, and we're going to add that last third pillow. And that goes right down the throat like the other ones. This reaction will leave us with, once we invert it here a few times, will leave us with basically, if oxygen is present and this chemical reaction occurs, so we invert a couple of times, remember to hold that top on, we end up with basically a urine yellow sample here. And that's proof positive that oxygen is in the water. If it didn't turn a yellow and went clear, then there is no oxygen in the water, which would be very, very bad. What we're going to do now is we're going to move inside where there's a little bit more light, because we're going to do a titration on this water and see where we sit for dissolved oxygen. Okay, we're inside where we have a little bit of light. Now what we're going to do is we're going to take our sample, which you can see with the white behind it is a nice yellow in color, and we're going to measure using the small vial here. We're going to top that off, okay, right up to the top. Alright, and then we're going to pour that. Basically we're just measuring here the proper volume. We're going to take that and pour that into our titration bottle. Okay, you can see we've got a yellow here, and what we're going to do is we're going to titrate with the sodium thiosulfate here. We're going to titrate into that bottle. Okay, so all we're going to do is count drops here, 1, and we're going to shake in between each drop, 2, 3, and what we're looking for is that 4, that liquid in the square vial here to go clear. 5, getting close. 6, still yellow. 7, 8. Okay, we might be there. Let's take a quick close look at this. Get a little closer. I think, might be hard to see in the video, but I think we need to go one more. So we're going to go 9. This is number 9 here. Okay, give it another quick shake. Alright, we're clear there. So it took 9 drops to titrate this out to a clear solution. It's always a good idea to go with a white background here. You can definitely tell the difference. If you're outside, which is typically where you would do this, it's pretty hard to tell here what color that is with a different colored backdrop, or if you're doing it in front of other things. So having that white backdrop, in my opinion, is quite important. Okay, final thing, if you're doing this test with us down at the river, all of the liquids, whether it be your titration or the original test solutions here, should all be placed in the waste bucket, and rinse all of your test glassware or plasticware, in the case of this guy, with distilled water down at the river. Do not pour anything out onto the grass or release any of these liquids back into the river. Final thing, we'll go ahead and do a percent dissolved oxygen, and we'll be looking at a test card here in a second. Okay, lastly, what we need to do, and included in the directions here, is to calculate the percent saturation of dissolved oxygen in the water at our given temperature. Our temperature out at the creek, which I did not show you, but I did measure, that temperature was 17 degrees Celsius. And we had 9 drops, which equates to 9 parts per million. So the temperature we can see here, and the drops or parts per million will be seen here. And what we're going to do is we're just going to simply line up those two numbers here across our percent saturation here. So I'm going to do that and get right back to you. Okay, for demonstration purposes only, I've written on this card, and you can see I've matched the 17 degrees Celsius with my 9 drops, or 9 parts per million. And that line then comes out, being careful to read the scale correctly, comes out at 95% saturation. So we'll do one last look here with a Q value from our book, and we'll be all set to assign a value for dissolved oxygen for this test. Okay, we're going to use the field manual for water quality monitoring now, and we're going to turn to page 62 to calculate our Q value. Okay, on page 62 we find the Q value chart, and we use the bottom scale to find 95. From there we go up on the chart and read across on the y-axis and find that we're at 97. Okay, lastly what we do is we add our values onto our test sheets. You can see the date, time, weather, test results. The Q value was 97. We're going to multiply that by 0.17 to come up with a total of 16.49. Once the other remaining 8 tests are completed, we will have a total value, and we can assign an overall water quality to the river at that point.